Hello, welcome everyone. Today we are doing displacement, time, velocity, acceleration. That is, today we are starting forces and motion, and in that we will be doing what is acceleration, velocity, their relation. So let me start with it. Before that, I'm running a crash course for GCSE for all subjects. So if you want to enroll, just email us at exacademy@gmail.com, and they are very affordable and the groups are very small. So definitely it's gonna be a very interactive classes. So you know what, the recorded sessions and the live sessions are completely different. So let me start with this. Before I start with any quantity, I'm starting with scalar and vector. That I always do. Even in my classes, I always start with scalar and vector because that will help us in understanding how to calculate vector, how to represent it, and so on. So scalar are those quantities that have only magnitude. A magnitude that means a value. Say for example, I'm saying the time is 3 seconds, like past 3 seconds, or right now the time is 4 hour, 3 minutes, or whatever your time is, 4 o'clock, 5 o'clock. So you are not representing it with a negative one, right? Similarly, if I say my height is 5'5", so I can't say it's negative. So obviously there are some quantities where I can't specify the direction. Negative I am saying because in mathematics or in physics, when I write it down, I represent vector with negative sign. Because if I'm talking about something, I don't know the specified direction, but I would be knowing that whether it's moving in same direction or opposite direction. So if it's a vector quantity, I can represent it with a negative sign. Or in short, for these quantities I can't specify any direction, like in which direction my height is, or in which direction like the time is moving. So these are scalar quantities. So I can say mass, time, distance, height. These all are scalars. Whereas for the vector quantity, I can specify my direction. So I'll let you know, I'll explain you when we'll do displacement and distance. You can clearly understand there that how we can specify the direction of some quantity and for some we can't. So examples are displacement, velocity, acceleration, force, etc. So I'm starting with the first one, which is important, is distance and displacement. If there are 2 points A and B, and a man is moving and tracing this path, my question is what is distance? So definitely whatever he has covered while moving in this curvy path, that will be the distance covered by the person. So how much a body or a particle has traveled? It actually traveled that one. But when I talk about the displacement, then displacement would be a different thing. Displacement is just the shortest distance between A to B, or if you draw a straight line connecting the initial and the final position, simply when the consideration of the initial and the final position is given, initial and final position, or with respect to something, if we are calculating that is the displacement. Even if you uh, think about the word displacement, what is displacement? That means how much a particular body has displaced itself. You're not it's not important to know like what path it has traced, but how far is it from the initial position, that will give you displacement. So displacement is the distance between initial and final position. This is the shortest distance between the 2 points. Now, important thing is, I told you I'll be clearing what is vector and scalar quantity. If I talk about the distance, distance is the green path. Green path, that means can I specify the direction of this green path? No, because there's no particular direction of it. So this is the reason distance is a scalar quantity, because you can't specify its direction. Whereas for displacement, I can definitely. I can say that I have moved from A to B towards east. I have specified my direction, because if it's a straight line between the 2 points, you can easily specify its direction. And this is the reason displacement is a vector quantity. So this is the basic difference between distance and displacement. And this is the reason I can represent distance with only positive value, 30, 40, 50 kilometers, 30 kilometers. Whereas for displacement, I can specify the negative value as well. I can say negative 200, positive 200. If I'm saying positive 200, that means in forward direction or in a particular direction, this is the distance traveled by man. If I'm saying negative, that means maybe he has covered in opposite direction. So this sign represents the direction when we calculate something. Next is velocity and speed. So speed is definitely how fast you are moving or how slower you are moving. And simple is that they are just asking you how much a distance is being covered in a particular interval of time. And this is the reason the formula is distance over time. That means how much distance is covered per unit time. How much distance is covered in a unit time. Now the units are kilometer per hour, it can be kilometer per hour, it can be meters per second. And coming to the most important thing, whether it's a scalar or a vector quantity. See, it's because it's a distance over time, this is a scalar quantity. You cannot specify the direction of your speed. So it's always going to be a very positive answer that you can write. So this is a scalar quantity. And this is why we can represent it only with positive value. Now if I talk about the velocity, velocity is displacement over time. Displacement over time, just like speed is distance over time, velocity is displacement over time. It's a standard unit, we always use meters per second for it. Now how much a body has displaced per unit time, that will describe its velocity. That means I can say how much a body has displaced in given interval of time. Now I can represent it with negative sign as well. So it can be represented by positive as well as negative sign, positive and negative signs. Let me understand it with the help of displacement time graph. That how can I represent velocity, what a velocity looks like when I draw a displacement time graph. See the displacement time graph. On y-axis we plot the displacement, on an x-axis we plot time. I can write displacement, which is in meters, and time, which is in seconds. Displacement and time. See, if you're looking any graph, you should know that the gradient of that particular graph is giving you what, because gradient is very important. Gradient tells you that one quantity, how one quantity is changing with respect to another quantity. So gradient is important. And also area under curve, like if you find the area under that given curve, it also gives you some. So these two are very important. Just by looking even at a random graph, you should know that what will be the gradient and what will be the area under curve of this graph will give me. And there's a simplest way to understand that. If I talk about gradient, gradient is a slope or steepness you're calculating, or simple how one variable is changing with respect to another variable. It tells you that. But the way to calculate the gradient is change in y over change in x. how much y is changing and how much x is changing. What is written here on y-axis? It's displacement. That means it's change in displacement or displacement over what is written on x-axis? Time. That is time. So gradient of this graph is displacement over time. And what is displacement over time? We just saw displacement over time is velocity here. That means the gradient of this graph will give me velocity. Now, area under curve, whenever I calculate the area, doesn't matter whatever the formula I'm applying, but ultimately I'm multiplying two different dimensions. Two dimensions are being multiplied and then we can get the area. Like length into width is area of rectangle, length into length is area of square, half times base times height is area of triangle. For circle it's pi r squared. So it doesn't matter, the formula is changing, but you can clearly see area is every time multiplying the two dimensions. That means if I'm finding the area under curve, doesn't matter what kind of figure is it, you are multiplying two dimensions. What two dimensions? X-axis and y-axis. On x-axis it's written time and on y-axis it's written displacement. Now you have to think, what is displacement into time? It's not any known quantity that we are studying. So there's no use of area under curve for us at this point of time. So you have to find the gradient and area under curve just like that. It will give you idea that what kind of quantity will you get. Now let me see the different types of curves on displacement time graph and what they are representing. See, the first graph is displacement time. It's like this, this, and this. See, if I name it A, B, C, and D. A, B, C, D. Only I'm talking about one by one. A to B, how the curve is moving or what kind of motion from A to B this curve is telling us. From B to C. See, graphs are a way to tell us the things very quickly rather than if you have a whole data in a table or a raw data, looking at that, or if you have plotted it in a form of a graph, that is just way easier to understand it. Just by looking at it quickly you can tell us, okay, the curve is showing me this. And that's the advantage of making curves or graphs. So A to B, B to C, and C to D. If I talk about A to B, first of all, what kind of A to B is? What geometrical figure is it? It's a straight line. And we know that the gradient of a straight line is always constant. The most common mistake that a student does is it says increasing velocity. No, velocity is not increasing at all. Why? Because if you pick this point, suppose this is 1, 2, 3. This is 1, 2, 3. Let me find the gradient by taking these 2 points. This 2 points represent 2, 2. This points represent 3, 3. So change in y is 3 minus 2. Change in x is 3 minus 2. Answer is 1. Let me pick this point 0, 0 and 2, 2. So change in y is 2 minus 0. Change in x is 2 minus 0. Answer is 1. So clearly you can see that the gradient is, doesn't matter which 2 points you have selected, or at any point the gradient is 1. Here, 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 everywhere the gradient is just 1. It represents that the gradient is constant. And what is the gradient of displacement time graph? The gradient of displacement time graph is velocity, which means your velocity is constant. So gradient of a straight line I'm representing writing straight line as SL. A gradient of a straight line is always constant. But what kind of value you are getting? You are getting a positive value. So you can say gradient is positive. It's constant. But what value constantly you are getting? 1, 1, 1. What was 1? Positive value. And what is the gradient of this graph? Velocity. So as gradient of this graph is velocity, so I can say that velocity is constant and positive. So a positive constant velocity. This is the motion from A to B. Now from B to C, if you see, obviously, if I pick this point, if I pick this point, if I pick this point, if you calculate the gradient, you will get gradient as 0. Sometimes a student gets confused, so you can do it either way. First of all, you can clearly see, suppose this is 3 here. This is 4, 5, 6, 7. If I pick this point, this is 4, 3. This point 6, 3. This point 7, 3. So what you can see here, you can clearly see that from B to C the time is changing, time is increasing, but displacement is exactly the same. It's not changing at all, which means that it is stationary. So this is a stationary point. Stationary, or simply you can say not moving. Now there is another way by which you can calculate gradient. Gradient is same as I told you. This point is 4 comma 3 and this point is 7 comma 3. If you calculate gradient, change in y is 3 minus 3, 7 minus 4, which is 0. Gradient is velocity. Velocity is 0. Velocity 0 depicts something is not moving at all. So in either way you can understand this. I later, when we will doing the velocity time graph, I'll explain you one thing that is also a very common mistake. So we'll be discussing that. So stationary, not moving. Then C to D. From C to D, again, because it's a straight line, even you don't have to take points and calculate. As long as you see a straight line, that means it has a constant curve, a gradient. That's it. So C to D is a constant gradient. But what's happening here? The one quantity is decreasing. Which quantity? Displacement is decreasing. It's easy. Here on right hand side from A to B, both the values were increasing. You can clearly see displacement is increasing, so does the time. So you can clearly understand that this is a positive gradient. Whereas from C to D, one value is increasing, other is decreasing. And when this happens, you will always get a negative gradient. So this is a negative constant velocity. Now let me see another curve. Suppose in this curve, this is same I'm drawing for displacement time. And I'm getting a curve like this. Now keep in mind, for a straight line gradient is always constant, but not for a curve. For a curve, the velocity here, or simple, for any curve, the gradient is always different at different points. And if you have done this in mathematics, so you might be knowing that to calculate it, you have to draw the tangents at every point. Why we are drawing tangents? Because tangent is showing us the gradient, steepness at every point, which shows that every point has a different gradient. So clearly, if every point has a different gradient, that means every point has a different velocity. So it's a non-constant velocity curve. You will not get a constant velocity here. And when the non-constant velocity, or when velocity is changing continuously, we say it's accelerating body. So after that we are going to study acceleration definitely. So that's why I have introduced here. If a body is moving with different velocity, doesn't matter if it's increasing, decreasing, but it keeps on changing. It can increase, it can decrease. That means the body is accelerating. So here I can say that as gradient of a curve is variable at every point, so we can say velocity is different at every point. And if velocity is different at every point, that shows that this is an accelerating body. So it's an accelerating body. And now the next thing that we are studying is acceleration. Acceleration I just talked about, that when velocity is not constant. So when velocity keeps on changing, we can say that particular body is accelerating, and that is called acceleration. So how you can define acceleration? The change in velocity over time is called acceleration. And the formula to calculate acceleration is the same, that is change in velocity per unit time, and that I can write in a formula method, change in velocity over time. Change in velocity, that means how much velocity has changed from starting to end. So we will take two velocities only. We don't care about how many velocities you're changing in between. The main is your initial and the final velocity. As I told you, vector depends on your initial and the final position, and acceleration is a vector quantity. So we are talking about the final and the initial points. So this will be, change in velocity will be final velocity minus initial velocity over time, and this is acceleration. So acceleration is represented with A, final velocity is represented with V, initial velocity is U, and T is time. Always remember, we represent V with final velocity, U is initial velocity, A is acceleration, and T we all know is time. And unit of velocity is meter per second, just like I told you. Acceleration is, see, what is unit of velocity? Meters per second. Over time, which is seconds. So it will be meter per second squared. That's the unit. Now let me see the velocity time graph. So this is our velocity time graph here. Velocity time graph. Also, the same thing we have to do it here. That means the first aim is to know what kind of or what value you will get when you find the gradient. So if I draw velocity is on y-axis, which is in meters per second, time is in seconds. Gradient is what? Same, gradient is change in y over change in x. What is written here on y-axis? Change in velocity. So change in velocity. M is gradient. Y is equals to mx plus c. What is m there? Gradient. So that's why I'm representing gradient with m. So change in velocity over change in x-axis is time. So change in time. So what is velocity over time? We just saw acceleration. So gradient is acceleration. So I can say gradient of velocity time graph gives acceleration. The second thing was area under curve. So that I'll explain you once I'll draw a curve. Same, first I'm drawing the same type of curve, and here I was talking about there is a most common mistake the student does. Here I'll explain. You can check by yourself as well whether you have done it or not. This is A, B, C and D. Same, let me see what is the kind of motion from A to B, from B to C, from C to D. From A to B, simple, straight line. Straight line has a constant gradient. Gradient is acceleration. That means A to B is constant acceleration. And both the quantities are increasing. So it's a positive acceleration. So I can say I applied the same logic that I applied in displacement time graph. Only the difference was there the gradient was velocity. Here it's acceleration. So I can say it's positive acceleration. Now from B to C, stationary, right? That's the most common mistake. It's not stationary, right? Because if you take this point, suppose this is 3, this is 2, 3, 4, 5. So if I take this point, this will be 2 comma 3. If I take this point, this will be 5 comma 3. X is changing, time is changing, but what's constant? Your velocity is constant. If velocity is constant, can I say it's stationary? That means at second when it was 2 second, the body was moving with 3 meters per second. Then after some time, the body is still moving with 3 meters per second. Velocity is constant. The rider has kept his velocity constant and set it at 3 meters per second, but it's still he's moving. So you can't say stationary. It's a constant velocity. So this is the most common mistake that I've seen generally the student does. They always just quickly give the answer, stationary. This is constant velocity. From C to D, it's constant deceleration. When you have a negative acceleration, we call it as a deceleration. So constant negative acceleration or deceleration. So this is the basics of the curve, right? Now let we see one more thing I told you, area under curve. Area under curve, this is a trapezium. If you will calculate the area of a trapezium, what is you're doing? Half times a plus b, that means sum of the parallel side into the height or the distance between them. What you're doing is still multiplying two different dimensions. So if you are calculating area, still you are multiplying different dimensions. Which two dimensions? Velocity and time. Velocity and time you're multiplying. And think, what's the quantity which is velocity into time? That's displacement. So obviously velocity is displacement over time. So displacement is velocity into time. So we can calculate displacement, and not only displacement, distance as well. And when we'll be doing question, I'll explain you what's the difference between displacement and distance. That means from the same curve you can calculate displacement and distance. Now you would be saying, so we should get the same answer? No, we shouldn't get the same answer in that case. Let me see. So this is the important thing, that area under curve of a displacement time graph velocity time graph is displacement and distance, both we can calculate. Now let me see what's the difference between calculation of a displacement and calculation of a distance. This one, suppose you have a curve like this. You are calculating area. Suppose area of this figure is 14 centimeters squared. Area of this is 12 centimeters squared. Distance will be sum of area. That means I can say distance is equals to 14 plus 12, 26 centimeter. This is 14 and this is 12 centimeters. So this will be 26 centimeter. Whereas if I'm calculating displacement is a vector quantity, and if something is moving in negative direction, we have to take the sign negative. Here your displacement, your velocity is positive, your time is positive, obviously area will be positive, so 14. But here your velocity is negative, you are multiplying it with negative, so here we have to write negative 12 plus negative 12. Why we have taken negative? Because displacement is a vector quantity, and negative velocity we have, so that's why it should be a negative. Answer is 14 minus 12, 2 centimeters. And you can clearly see from the same graph, method is exactly the same, we get the different things. Distance is different, displacement is different, and that's because of the sign. And one is vector and one is a scalar quantity. And this is the sole reason I started this whole topic by the vector and scalar one. So this was about the whole graphs that I have explained. Mostly you will find the graphs of acceleration, displacement, time. Okay, one more curve, and that's, I think you can easily tell about this graph. Same, I'm drawing velocity, time graph. Now it's a curve. Same, a curve has a different gradient at different point. Gradient of velocity time is acceleration. That means this curve has a different acceleration at different points. So I can say it's a non-constant acceleration graph. So in this, I'm covering graphs only. I'm not saying displacement, velocity, it's only graph. We definitely have to do questions, and we definitely have to see algebraic way how to solve. This is by the graph you can calculate acceleration, velocity, displacement. And what about when you have to do it algebraically? So that we will be doing in the part 2 of displacement time and velocity. So I think that's it for today, and again I'll be telling, if you want to enroll a seat, or if you want to book a seat for any class from year 1 to year 13, we have tutors for all the subjects. They are subject matter experts, and if you want for one-on-one or even for batches, just drop us an email at exacademy@gmail.com. So that's it for today. Thank you and have a great day.